Welcome to Dreamtime Science, where curiosity meets tranquility and knowledge flows like a gentle stream. Here we explore the wonders of our universe at a pace that soothes the mind. You know, I've been thinking about how everything around us, every word we say, every picture we see, even the tiniest cells in our bodies, relies on something called information. There's something remarkable about how this invisible thread connects all these pieces of our world in ways we usually don't notice. Tonight, I want to quietly explore with you what information really is and why, in a way, it's like the secret language that everything depends on. If you find peace in these nocturnal discoveries, consider becoming a regular visitor to our quiet corner of science. Share in the comments what topic you'd love to dream about next. Now, take a moment. Adjust your blanket. Find the perfect hollow in your pillow. Let your shoulders melt. Breathe in and out. In the hush of night, as the world settles and the mind grows receptive, let us embark upon the delicate unspooling of an idea that both binds and liberates, the concept of information. Not the news headlines that flicker across screens, nor the whispered secrets traded in playgrounds, but that deeper, more elemental substance that underlies understanding and meaning itself. Information, a word so familiar yet so protean that it slips through our fingers even as we try to grasp it. Tonight we begin not with definitions, but with a story, a tale as old as humanity's urge to communicate. In the earliest days, before ink dried on parchment or signals flickered through wires, our ancestors spoke in the language of gesture and firelight. Consider the ancient campfire, encircled by shadows and faces aglow. A storyteller gestures skyward, tracing with her hands the path of a great bird across the heavens. Her listeners lean in, eyes wide, as she paints the sky with her words. There is no codebook, no alphabet, but meaning flourishes in the shared space between speaker and listener. Each motion, each intonation is a symbol, a vessel for information, carried across the tenuous bridge of attention and memory. Herein lies the inception of information, not as a physical entity, but as something woven from intention, recognition, and context. Information is not the sound itself, nor the fire's crackle, nor the bird overhead, but the pattern that emerges when one mind reaches out and another receives. In this sense, all communication is a symphony of symbols, each note playing upon the instrument of human perception. As centuries unfurled, the symbols grew more intricate. Clay tablets bore the impressions of cuneiform. Papyrus unfurled beneath styluses that danced and etched. The alphabet, that miraculous invention, distilled the chaos of speech into repeatable, transferable marks. With every evolution, the question deepened. What is information, truly? Is it the ink on the scroll, the shape of the letter, or the meaning it conjures in the reader's mind? In the slow march of history, the notion of information became entangled with power and secrecy. Kings dispatched messengers with coded scrolls, generals whispered strategies in cipher. The Greeks crafted the satale, a staff-wrapped strip of parchment that revealed its secrets only when coiled upon the correct rod. Information here became a thing to be hidden, revealed, protected, a treasure of the intellect. Yet for all its practical uses, information eluded simple definition. Philosophers mused upon its nature, asking whether it resided in the medium or in the message, in the sign or the interpretation. Plato, in his dialogues, spoke of the forms, ideal, abstract entities that exist beyond the mutable world. In a sense, information is akin to these forms. It is not the paper, nor the ink, nor even the word, but the pattern that persists across countless instantiations. The age of science brought a new rigor, and with it the beginnings of quantification. consider the work of Samuel Morse, who transformed the dot and dash into a lifeline for distant souls. The click of a telegraph key became the pulse of history, encoding news, hope, and sorrow in its staccato rhythm. Here, at last, was information rendered countable, reducible to sequences and intervals. But it was in the 20th century, with its fevered dreams of computation and transmission, that the idea of information blossomed into something both profound and paradoxical. Claude Shannon, a quietly brilliant engineer, gazed upon the tangled wires of telephone exchanges and saw not mere noise, but order, the possibility of quantifying uncertainty itself. In 1948, his mathematical theory of communication offered a definition both simple and revolutionary. Information is that which reduces uncertainty. Bit by bit, symbol by symbol, Shannon's theory recast information as measurable, manipulable, and above all, separate from its physical embodiment. This abstraction, so elegant and powerful, rippled outward into every corner of science and technology. Suddenly, the world was awash in bits, not just in computers, but in biology, physics, and even the arts. The DNA in every cell could be seen as a message written in a 4-letter alphabet. The dance of particles in a gas encoded the hidden statistics of entropy. Information became a bridge between the tangible and the intangible, the seen and the unseen. Yet as the vocabulary of information spread, so too did its myths. Popular culture, always eager to dramatize and simplify, seized upon the idea with gusto. In the pages of science fiction, information became a substance more potent than matter or energy, a force that could be wielded, weaponized, or even stolen. Consider the classic trope of the uplink, the hero, surrounded by blinking monitors, downloads the secret plans in a shower of ones and zeros. The information is treated as a precious cargo, a payload that can be moved, copied, erased. In these stories, information is almost a physical thing, with mass and momentum obeying its own set of secret laws. Or recall the fevered imaginings of cyberspace conjured by William Gibson and his literary descendants. A realm where information flows like water, forming rivers and oceans of data, where hackers surf the currents and dive for digital treasure. Here, the boundaries blur between code and consciousness, between mind and machine. Information becomes the landscape itself, a place to be explored, conquered, or lost. Even the language of modern technology echoes these metaphors. We speak of bandwidth as though it were a highway, of bottlenecks and firewalls, of streams and clouds. Each term borrows from the physical world to describe something fundamentally abstract. Yet beneath these images lies a deeper truth. Information, for all its potency, is not a substance, but a relation. It is not a thing that exists independently, but a property that emerges when one system becomes correlated with another. To possess information about something is to possess a mapping, a correspondence, a structure that echoes the world. This subtlety is often lost in the fever dream of science fiction. One enduring myth is that information can be separated entirely from its medium, as though the soul might be stripped from the body and stored on a disk. In countless tales, a mind is uploaded, its patterns translated into code, its essence preserved in silicon. The fantasy is seductive, immortality by means of perfect copy. Yet the reality is more nuanced. Information cannot exist without a substrate, a canvas upon which its patterns are drawn. The brain's memories are not ethereal, but encoded in the shifting strengths of synapses, the chemical cascades and electrical storms of living tissue. To move information is to rearrange the world, however subtly. To copy a mind is to build a new edifice, molecule by molecule, neuron by neuron. Another myth, equally persistent, is that information is always valuable, always meaningful. In the fevered churn of the digital age, we are deluged by data, petabytes of messages, images, and code. Yet most of this torrent is mere noise, repetition, redundancy, the hum of background static. True information, in Shannon's sense, is rare and precious. It surprises, it enlightens, it reduces uncertainty. The rest is the digital equivalent of silence. Science fiction, in its exuberance, also delights in the notion of pure information, a message that transcends language, culture, even biology. Alien signals are decoded with mathematical ease. Ancient codes unlock the secrets of the universe. The fantasy is of a Rosetta Stone that unites all minds, all times. Yet real communication is always bound by context and convention. A message only informs if the receiver can interpret its symbols, if the bridge of meaning is built from shared experience. To a being without eyes, a painting is meaningless. To a mind without language, a book is mute. Here we encounter the delicate interplay between information and meaning, a distinction often blurred in everyday speech. Information, in its most technical sense, is a measure of uncertainty, a count of possible alternatives. Meaning, by contrast, is the resonance that occurs when information fits into a tapestry of knowledge and expectation. The same sequence of letters can be gibberish or revelation, depending on the mind that receives it. This distinction is the source of many confusions and myths. The cryptographer can measure the information content of a coded message, but not its meaning. The computer can shuffle symbols with perfect fidelity, yet remain oblivious to their significance. The map is not the territory, the code is not the concept, and yet, for all these caveats, the notion of information retains its allure. It is the thread that stitches together the sciences, the link between mind and machine, between physics and philosophy. In the quiet hours, we sense its presence everywhere, in the spiral of a seashell, the pattern of falling rain, the whisper of leaves in the wind. Information is the possibility of order in a universe teetering on the edge of chaos. The myth-makers are not entirely wrong, then, to see information as a kind of magic, a force that shapes worlds. But the magic lies not in the symbols themselves, but in the dance of correlation and interpretation that brings them to life. Each message is a bridge across the abyss, a reaching out from one mind to another. Even the most advanced science fiction, with all its digital sorcery, cannot escape the constraints of context and embodiment. The dream of pure information, unmoored from matter, remains just that, a dream. Yet it is a dream worth pondering, for in its pursuit we glimpse the very edges of what it means to know, to remember, to be. As the night deepens, let us linger for a moment on the image of the symphony, a tapestry of notes, each meaningless in isolation, yet wondrous in concert. Information is like this, a pattern that emerges from the interplay of parts, a melody that arises only when the symbols find their place. The Symphony of Symbols is ongoing, unfinished, ever-evolving. And so, as we drift between waking and sleep, the question persists, unresolved and alluring. Where do these patterns come from, and what, ultimately, do they reveal about the world and ourselves? The story of information, its origins, its representations, its myths, unfurls before us, a river yet to be fully charted, a song whose last verse is still unsung. Drift once more into the boundless corridors of thought, a place where the very fabric of reality shimmers with unseen messages, and every whisper of existence is encoded with meaning. As you lie still, imagine yourself transported into a vast labyrinthine maze, not built of hedges or stone, but woven from the raw substance of information itself. Here, walls are lattices of logic, and corridors twist through webs of signals and unseen patterns. This is not a maze meant to confound, but rather one that entices the mind to wander, to probe, to ask, what is information? How does it manifest? And what are the limits of what can be known? Begin with the simple act of perception. Open your senses in this infinite maze. In the darkness, a faint glimmer, a single bit, appears, the most basic atom of information. In its binary perfection, a bit is either one thing or another, yes or no, on or off, presence or absence. It is the smallest unit from which all messages, all meaning, all knowledge must be constructed. This fundamental duality echoes throughout the universe, as if the cosmos itself had been written in the language of choices and alternatives. But even as the bit pulses before you, you sense the maze stretching far beyond this simplicity. With each step, the path branches and the landscape grows richer. Bits gather into bytes, bytes into words, words into sentences, and soon the tapestry of information swells with complexity. The air hums with the possibilities of arrangement and context. Each configuration, each sequence, becomes a new message, a new story, a new potential for understanding. Yet information does not only exist in the explicit, the digital, or the written. It thrums in the analog world as well, in the gradient between darkness and light, in the subtle modulations of a violin's note, in the gentle undulation of a summer breeze. Here, information is continuous, flowing like a river, impossible to pin down to an exact number of bits. Even the most precise measurement is only an approximation, a shadow of infinite detail. As you wander deeper into the maze, you encounter curious forms of information, each with their own peculiarities. There is the genetic code, inscribed in the twisting helix of DNA. 4 letters, A, T, C, and G, repeating in unfathomable combinations, encoding the instructions for life itself. The sequence is precise, yet its meaning depends on context, on the machinery that reads and interprets it, on the environment in which it unfolds. Nearby, the maze offers another form, the neural code. Here, information is not written, but fired, electrical pulses racing through networks of neurons, each spike a potential signal, each pattern of activity a possible thought or memory. The language is one of probability and potential, where meaning emerges not from a single message, but from the collective chorus of billions of cells. In yet another alcove of the maze, mathematics itself becomes a vessel of information. Numbers and symbols, arranged according to precise rules, encode truths that seem to exist outside of time. A theorem whispered through the corridors of logic contains within it a universe of meaning, and yet, to unlock it, one must possess the key, the knowledge of the language in which it is written. And so the forms of information multiply, the flickering dance of photons across a camera sensor, the vibrations of air molecules that become the spoken word, the arrangement of pixels that coalesce into an image. Each is a translation, a mapping from one domain to another, a delicate balance between fidelity and economy. The maze is alive with transformations, with codes and ciphers, with the perpetual interplay between signal and noise. But what is information, truly? Is it merely an arrangement of symbols, a collection of data points, or is it something more, a measure of surprise, of uncertainty, of the unexpected? Here the maze unveils one of its most profound chambers, the realm of entropy. Climb a spiral staircase and let your mind drift to the work of Claude Shannon, the father of information theory. In his seminal insight, Shannon realized that information is not just about the content of a message, but about its unpredictability. A string of repeated symbols, A, contains little information, for it tells us nothing new. But a sequence like XWZKTL is ripe with possibility, each letter narrowing down the space of what could be. The information content is measured by how much the message surprises us, by how much it reduces our uncertainty about the world. This insight transformed not just the science of communication, but our very understanding of knowledge itself. Information became, in a sense, the currency of order and disorder. The more unlikely an event, the more information it carries. The more predictable a system, the less there is to learn from it. Thus, the maze itself seems to pulse with entropy, with the ceaseless dance between chaos and structure. Pause for a moment in a chamber filled with echoes. Here, the limits of understanding begin to reveal themselves. For every message, there is noise. For every signal, there is interference. The universe itself is not a perfect transmitter. It is a place of friction and loss, of signals muddled and obscured. No matter how carefully you encode a message, some part of it may be lost on its journey, degraded by random chance, by the static of the world. The maze whispers of the limits imposed by physics, the speed of light, the energy required to transmit a signal, the finite capacity of any channel. All these place boundaries on what can be known, on how much can be conveyed, on how clearly one mind can reach another. Even the act of observation is fraught with uncertainty. In the quantum world, the very process of measuring a system alters it, collapsing a haze of probabilities into a single, irreversible outcome. The information you gain is bought at the price of altering the reality you seek to know. Move now through a gallery of paradoxes. In one alcove, you find the phenomenon of the infinite library, a thought experiment conjured by Jorge Luis Borges, where a library contains all possible combinations of letters in books of a fixed length. Every work of literature, every true statement, every falsehood, every story yet unwritten, all are present, lost in a sea of gibberish. The sheer immensity of possible messages swamps the meaningful ones, and the challenge becomes not the creation of information, but the extraction of meaning from the chaos. In another corner, you encounter the puzzle of compression. How efficiently can a message be encoded? Is there a way to distill its essence without loss? Mathematics tells us that some messages are incompressible, that they are already in their shortest possible form. Here, the limits of understanding are encoded not in the content of the message, but in the structure of language itself. There are messages that cannot be understood in isolation. Their meaning depends on context, on prior knowledge, on a shared web of references and assumptions. This is the realm of semantics, of meaning beyond mere syntax. A single phrase can carry different significance depending on who hears it, when, and where. The maze grows denser here as corridors overlap and twist back upon themselves, and the search for understanding becomes a journey not just through data, but through relationships and histories. Consider, too, the paradoxes of self-reference. In the heart of the maze stands an ancient riddle. This statement is false. If it is true, then it is false. If false, then true. Information can loop back upon itself, twisting logic into knots, revealing the boundaries of formal systems. The mathematician Kurt Gödel showed that in any sufficiently powerful system of logic, there are true statements that cannot be proven within the system. These are the hidden chambers of the maze, forever locked, their contents glimpsed only through hints and shadows. As you wander still deeper, you come upon the territory of the unknowable. There are questions that have no answer, messages that can never be decoded, patterns forever beyond our reach. The mathematician Alan Turing demonstrated that there is no universal method to decide whether an arbitrary computer program will halt or run forever. A boundary not of technology, but of logic itself. There are problems that are undecidable, truths that are unprovable, patterns that shimmer just beyond the veil of comprehension. Yet the maze is not a place of despair, but of endless curiosity. For every limit there is a new horizon. The boundaries of knowledge are not walls, but invitations to explore, to push further, to seek new forms of understanding. The forms of information multiply endlessly, the dance of molecules in a crystal, the pattern of ripples on a pond, the shifting alliances in a flock of birds. Each is a message, a signal, a story waiting to be decoded. Within this infinite maze, even the act of forgetting is a form of information. The erasure of a memory, the fading of a signal, the loss of detail, these too are part of the story. The second law of thermodynamics tells us that the universe tends towards greater entropy, that information is always at risk of being dispersed, of dissolving into noise. To remember is to fight against this tide, to carve islands of order in a sea of possibility. In the quiet heart of the labyrinth, you may sense the presence of a mystery deeper still. Is the universe itself an information processing machine? Are the laws of physics but algorithms running on a cosmic substrate? Some physicists suggest that reality is fundamentally digital, that the bits and qubits of information underlie all that we see and touch. Others argue for the primacy of relationships, of correlations, of meaning that transcends mere data. The maze grows ever vaster, its corridors branching into new dimensions. There is quantum information, where a particle can be in many states at once, where a bit can be both 0 and 1, entangled with distant partners in ways that defy classical logic. There is biological information, encoded not just in genes, but in the intricate interplay of proteins, in the patterns of development, in the signals exchanged between organisms. There is social information woven through cultures and histories, carried by language, ritual, and art. All the while the boundaries of understanding shift and shimmer like the walls of a dream. For every question answered, new ones arise. The infinite maze is not a puzzle to be solved, but a landscape to be explored, a symphony to be listened to, a story to be lived. And so you wander on, through chambers bright and dim, through corridors lined with secrets and surprises. The air is thick with the scent of possibility, each step a new choice, each turn a new path. The maze stretches before you, infinite and inviting, its mysteries unfolding with each breath, each heartbeat, each flicker of thought. Ahead, unseen, new realms of wonder await. The boundaries of the maze will dissolve and reform, leading you onward through the ever-deepening mystery of information and understanding, of knowledge and ignorance, of what it means to know and what it means to wonder. In the quiet dark, when the stars above are scattered like embers flung across the velvet sky, a deep yearning stirs in the human mind, a longing to understand, to unweave the tangled patterns of the cosmos, to draw from the silent heavens some utterance, some message, some ciphered truth about our origins and our fate. This yearning is older than any written word, older even than the myths our ancestors whispered around their fires. It is the impulse that led us to look upward, to track the slow dance of planets and the sudden flare of comets, to chart the cycles of the moon, not only as a guide for planting and harvest, but as a first tentative language exchanged with the universe itself. Yet the cosmos is vast and silent, and its messages are written in a dialect not meant for human tongues. The stars do not speak, nor do the galaxies shout their secrets across the abyss. Instead, everything, every photon, every trembling of space-time, every ghostly particle that sings through stone and shadow carries a fragment of information. To decode the cosmos, we have had to become translators, inventors, conjurers of tools and experiments that press the limits of our senses and our imagination. Consider first the ancient astronomers, the careful watchers who, with nothing but naked eye and patience, mapped the heavens. Their tools were simple: sticks and shadows, stone circles, careful records scratched on clay or bone. In Babylonia, priests tracked the wandering of Venus, drawing up tables of positions so precise that their echoes persist in our mathematics. At Stonehenge, the rising sun at midsummer was framed by slabs of rock, marking time's passage with a grandeur that outlasts empires. In China and Mesoamerica, scholars recorded eclipses and comets, their data etched into the annals of civilization. The information they gathered was, by modern standards, sparse and rough. But it was the start of something remarkable, a tradition of seeing, recording, and seeking patterns, of translating celestial rhythms into knowledge that could be shared, debated, refined. Often, these early astronomers could only guess at the causes behind what they saw, yet in their careful tabulations lay the seeds of prediction, and in prediction the glimmer of understanding. The cosmos began to yield its first faint signals. Ages passed, and our reach grew longer. The invention of the telescope was not simply a technological triumph. It was a revolution in how we perceive information. Galileo's crude, hand-ground lenses transformed pinpricks of light into orbs, revealed the moons of Jupiter as worlds in their own right, and exposed the rugged, shadowed face of our own moon. Suddenly, the universe was no longer a remote and untouchable tapestry. It became a place of detail, of structure, of subtlety, offering, to those who would look, a new flood of data. Astronomy's methods evolved in tandem with its tools. As the centuries unfurled, astronomers became ever more adept at coaxing meaning from the universe's faintest traces. Photographs replaced sketches, allowing for permanent, objective records. Spectroscopy split starlight into rainbows, unveiling not only the elements that blazed in distant suns, but their temperatures, motions, and ages. Each advance was a new way to listen, a new type of message for our growing lexicon, light in all its colors, bearing secrets from across unimaginable gulfs. Yet it is not only the grand sweep of the heavens that has demanded our ingenuity. To decode the cosmos is also to peer into the smallest, most fleeting phenomena, to devise experiments that tease out nature's most elusive truths. The story of information in the universe is, in many ways, the story of our creativity in formulating questions that the cosmos itself can answer. One of the earliest and most elegant demonstrations of this was performed not in some gleaming laboratory, but in a darkened room with little more than a cardboard tube and a candle. In the 17th century, Isaac Newton sought to understand the composition of light. By allowing a thin beam of sunlight to pass through a prism, he revealed that white light, far from being pure and uniform, was in fact a blend of all colors. In that spectrum, red to violet, was encoded a wealth of information about matter and energy. Newton's simple experiment opened a door. It invited future generations to devise ever more sensitive prisms, to build spectrometers that could analyze the light of distant stars, to infer the presence of elements and molecules in places we will never touch. This interplay of observation, innovation, and interpretation lies at the heart of every great leap in our understanding. Take, for example, the quest to measure the speed of light, a fundamental constant, a cosmic speed limit woven into the fabric of reality. For centuries, philosophers argued whether light moved instantaneously or at some finite pace. In the 1670s, Danish astronomer Ole Rømer found a clue in the motions of Jupiter's innermost moon, Io. He observed that the moon's eclipses by Jupiter appeared to lag behind schedule when Earth was moving away from the giant planet, and occurred sooner when Earth approached. This subtle timing shift, imperceptible to all but the most diligent observer, could be explained if light took time to cross the space between planets. With little more than careful watching and a keen mind, Rømer had measured the finite velocity of the universe's most fundamental messenger. Other questions required even stranger tools, and the courage to imagine experiments that bordered on the fantastical. In the late 19th century, Heinrich Hertz set out to prove the existence of electromagnetic waves, ripples in the fabric of the ether as they were then conceived. Using coils of wire, spark gaps, and sheets of metal, he made visible the invisible, radio waves generated and received, skipping across his laboratory. What had once been a mathematical abstraction now became a tangible, measurable phenomenon. Hertz's apparatus was unsophisticated by modern standards, yet it transformed our understanding of information itself, opening the way to the wireless age and the realization that the cosmos is filled with signals awaiting interception. As our tools have grown more complex, so too has our ability to ask and answer questions of ever greater subtlety. The 20th century brought with it a cascade of innovations: giant telescopes perched atop lonely mountains, radio dishes scanning the sky for whispers from pulsars and quasars, detectors buried deep underground, searching for ghostly particles called neutrinos. Each of these instruments is, in essence, a way of eavesdropping on the cosmos, a means of intercepting the information that the universe flings our way. Consider the remarkable story of the discovery of cosmic microwave background radiation, a faint, persistent afterglow from the birth of the universe itself. In the early 1960s, radio engineers Arno Penzias and Robert Wilson were testing a horn antenna, originally designed for satellite communication. They encountered a persistent background hiss, a noise that could not be eliminated by cleaning the equipment or shooing away nesting pigeons. It was, in fact, the echo of the Big Bang, the relic radiation from an epoch when the universe was a seething, incandescent fog. Hidden in that faint signal was a wealth of information: the age of the universe, its composition, its earliest history. What began as an annoyance became, through careful measurement and interpretation, one of the most profound discoveries of all time. The tools with which we decode the cosmos are not only instruments of glass and metal. Increasingly, they are tools of logic, mathematics, and computation. The information we gather from telescopes, from particle accelerators, from gravitational wave observatories arrives in torrents, far too vast for any single mind to comprehend. It falls to algorithms and simulations to sift through the data, to detect patterns invisible to the eye, to model the swirling dance of galaxies and the collapse of stars. In this age, the experiment often lives as much in silicon as in stone, and the boundary between observation and theory grows ever more porous. There are experiments so ambitious, so bold, that they strain the very fabric of possibility. Picture the Large Hadron Collider, a ring of tunnels buried beneath the French and Swiss countryside, where protons are hurled at one another at nearly the speed of light. Detectors the size of cathedrals record the debris of these collisions, searching for traces of particles that flicker into existence for the briefest instant. The discovery of the Higgs boson, a particle that endows others with mass, was not simply a triumph of engineering, but a testament to the power of hypothesis, of prediction, of seeking out nature's hidden architecture. At other times, the cosmos itself becomes the experiment, and we are merely its witnesses. When, in 2015, the Laser Interferometer Gravitational Wave Observatory detected the faint tremor of space-time caused by the merger of two black holes, it was the culmination of a century of theory and decades of technological innovation. The experiment was almost absurd in its delicacy. Laser beams sent down 4-kilometer arms, reflected by mirrors suspended in vacuum, all to detect a distortion less than the width of a proton. Yet in that whisper of a signal was encoded the violent dance of massive objects billions of light-years away, a story written in gravitational waves, read at last by human minds. Our methods continue to evolve, responding to the challenges that the cosmos sets before us. We have learned to listen not only to light, but to neutrinos, to cosmic rays, to the fleeting flashes of gamma rays from distant cataclysms. We have built arrays of radio telescopes that can link together across continents, synthesizing a virtual eye as large as the Earth itself. With this technique, called very long baseline interferometry, we have imaged the shadow of a black hole, peering into the maw of gravity itself. The information we extract from the universe is, in a sense, always partial, always filtered through the limitations of our instruments and our imaginations. Yet with each new tool, each new experiment, we come closer to a kind of dialogue with the cosmos, a way of asking questions and receiving answers, however cryptic, however faint. We have learned to read the fingerprints of atoms in starlight, to decode the ripples of space-time, to infer the presence of exoplanets from the wobble of distant suns. We are, in our own way, becoming polyglots in the language of the universe, able to translate the silent messages carried by matter and energy, space and time. And always there is the thrill of innovation, the sense that our greatest discoveries may yet lie ahead, hidden in the data, waiting for a new tool, a new experiment, a new way of seeing. Perhaps it will be in the shimmer of dark matter, or the flicker of a signal from a distant world, or the pattern of quantum entanglement that hints at deeper realities. The cosmos is not a book with pages to be turned, but a vast, ever-shifting code, one that we are only just beginning to decipher. Even now, as the night deepens and the stars wheel overhead, somewhere a detector records the faint passage of a particle. A telescope gathers the light of a star that died before our species was born. A computer sifts through data, searching for the telltale signature of a cosmic event. The work is never finished. The dialogue never ends. Each question answered gives rise to new mysteries, new challenges, new calls for ingenuity. And so, as the hush of the cosmos settles around you, consider the lineage of dreamers and doers who have brought us to this moment. The watchers, the builders, the experimenters, the translators of information. Their tools may change, their questions may evolve, but the impulse is eternal. Somewhere in the darkness, a new experiment waits to be born, a new signal to be decoded, a new message from the stars to be understood. The story continues, and with it, the gentle, unending unraveling of the universe's deepest secrets. In the hours when night settles deep and the world hushes itself to a velvet stillness, there is a peculiar quiet that seems to envelop not just the earth, but the whole of existence. It is in these moments, when the constellations wheel silently overhead, and the only sound is the faint susurrus of your own breath, that the fabric of information, the secret thread that weaves through every atom and every thought, becomes something almost palpable. Its presence is soft and omnipresent, like the gentle whisper of distant stars, a message carried across the yawning chasms of space and time. Information, at its most basic, is the answer to a question. It is what distinguishes one possibility from another, what tells us, on every scale, what is and what is not. Yet this simple notion, so easily stated, gives rise to the most profound mysteries. As you lay quietly, listening to the hush between your heartbeats, consider for a moment that the universe itself is not merely a collection of things, but a vast interplay of messages. Each photon that reaches your eye from a distant galaxy is not only a traveler of light, but a carrier of information about where it was born, when it began its journey, and the countless encounters it has endured along the way. What does it mean to say that the universe is woven of information? The question is as deep as space itself. It is tempting to imagine that information is merely a human invention, a convenient way to measure and compare. But long before the first mind awoke to the stars, long before the first question was ever asked, information was already at work. The arrangement of the first atoms, the folding of the first molecules, the choreography of the first living cells, each was a pattern, a selection, a message encoded in the language of reality itself. If you close your eyes and allow your imagination to drift to the edge of the observable cosmos, you might envision the great cosmic web, filaments of galaxies stretched across billions of light years, clusters of stars gathered like dew on a spider's thread. But what holds this vast structure together is not only gravity or dark matter, but the hidden order, the information that dictates where each star will ignite, where each galaxy will spiral, and how each black hole will shape its surroundings. The universe, in this sense, is a kind of living manuscript, an endless library, where the laws of physics are the grammar, and every event is a sentence written in the elemental alphabet of possibility. For generations, philosophers and scientists have pondered whether information is more fundamental than matter or energy. Some whisper that perhaps the cosmos itself is not a machine, but a computation, an ongoing calculation in which every particle, every wave, every fluctuation is an act of processing, a bit flipped, a choice made. This is the strange suggestion of digital physics, that the universe may be at its core a vast information processor, each instant a tick of some undetectable cosmic clock. Yet, even as we explore the mathematical underpinnings of this idea, there remains a mystery so deep it resists all equations. Information does not exist in isolation. It is always about something. It is always in relation. The shape of a leaf contains information about sunlight and water and wind. The DNA in your cells contains information about your ancestors, their triumphs and struggles, their dances and migrations across ancient landscapes. And the language you dream in, the stories you tell yourself in the darkness, are themselves information, messages shaped by history, biology, and the ineffable spark of consciousness. Here, then, we find the mystery at the heart of all things. What is the connection between information and meaning? For though every atom jostles with data, not every arrangement of particles becomes a poem, not every sequence of sounds becomes a song. Somewhere in the whirl of possibility, meaning arises, unexpected, irreducible, and profoundly human. How strange it is to consider that the stars above, so remote and indifferent, have nevertheless shaped the stories we tell and the questions we ask. For thousands of years our ancestors gazed upward, mapping the heavens, inscribing the sky with gods and monsters, with destinies and omens. The light from those stars was, in a sense, the first information humanity ever received from beyond this fragile world, a message written in photons, deciphered by curious minds. Astronomy, in this way, becomes not just a science, but a dialogue across the ages. Each new discovery, a faint signal from a distant pulsar, the spectral fingerprint of a molecule on a far-off planet, is an answer to a question someone, somewhere, once dared to ask. Here on Earth, the story of information and humanity unfolds in countless quiet revolutions. The first spoken word, whispered in the shadows of a prehistoric fire, was a new kind of message, a way to share dreams, to warn of danger, to pass on the knowledge of the hunt and the shape of the seasons. Language, that most astonishing invention, allowed the information stored in one mind to leap across the gap to another, to be replicated, transformed, and preserved. From language came writing, and from writing came civilization, a great network of memory stretching across centuries, each generation building upon the insights and mistakes of those who came before. In the modern era, the tempo of this exchange has quickened beyond anything our ancestors could have imagined. The digital age is built upon the recognition that all information, be it a sonnet, a sunset, a heartbeat, or a song, can be encoded in bits, the binary whispers of ones and zeros. The Internet, that shimmering web of data, now binds together billions of minds, making possible a kind of collective thought, a shared consciousness that transcends geography and time. Yet with this abundance comes a new kind of mystery. How do we sift meaning from the endless torrent? How do we nurture wisdom in a world where every signal is drowned in noise? Perhaps there is solace to be found in the realization that the search for meaning is itself an act of creation. Every time you listen to the night, every time you ponder the pattern of the stars or the pattern of your own thoughts, you are participating in the great unfolding of information into understanding. Each question you ask is a pebble cast into the stillness, sending ripples outward, touching shores you cannot see. But if information is so central, so intimate a part of the universe and ourselves, why does it feel so elusive, so ghostly? To physicists, information is both concrete and ephemeral. In quantum mechanics, the act of observation itself, the gentle measurement of a particle's position or momentum, creates reality from possibility, collapsing a mist of maybes into a single fact. Yet the quantum world also teaches us that information can never be destroyed, only transformed. Even when a star dies, even when a black hole evaporates, the information encoded in its structure is not truly lost, but scattered, hidden, perhaps, in ways we do not fully understand. This is the paradox at the heart of the black hole information problem, one of the greatest puzzles of modern science. If you were to drop a book, a literal book, heavy with words and meaning, into a black hole, classical physics would predict its utter annihilation. Yet quantum theory insists that the information, the pattern of ink on paper, the story itself, must somehow be preserved, encoded perhaps in the subtle ripples of space-time at the event horizon. In this way, the universe seems to guard information with a jealous intensity, as if the very act of forgetting were forbidden by cosmic law. And yet, for all this, information remains tinged with the ineffable. It is both the raw material of the world and the lens through which we comprehend it. It is the grain of sand and the poem about the sand, the vibration of a string and the music it becomes in the ear of a listener. This duality of information as both substance and meaning invites not only scientific curiosity but a kind of reverence. When philosophers speak of the hard problem of consciousness, they are, in a sense, confronting the greatest riddle of information. How does the mere arrangement of atoms and electrons, the firing of neurons and the flux of ions, give rise to the inner experience of being? How does the information encoded in the brain become the warm, shimmering tide of memory, desire, sorrow, and joy? No equation, however subtle, yet explains the leap from matter to mind, from pattern to poetry. Some have speculated that consciousness itself is a kind of information process, a recursive loop in which the brain becomes aware not only of the world but of itself. In this view, to be conscious is to be an interpreter of information, a translator of signals into stories, of sensations into self. But even this bold hypothesis leaves much shrouded in mystery. For the emergence of meaning, the birth of subjectivity from the cauldron of physical law, feels at once inevitable and impossible. Yet perhaps this is the gift that information bestows, not certainty, but wonder. The more we learn about the world, the more we recognize the vastness of all that remains unknown. Each answer unfolds into new questions. Each discovery reveals hidden depths. The journey from ignorance to understanding is a spiral, endlessly ascending, forever incomplete. It is in this spirit that humanity has always turned to the stars, not only for light in the darkness, but for a sense of connection, a glimpse of order amidst chaos. The ancient astronomers who mapped the heavens with trembling hands and burning curiosity were, in their way, the first information theorists. They sought patterns in the sky, rhythms in the movement of planets, messages in the turning of the year. And though our tools have grown more sophisticated, our questions have not changed. What is out there? What does it mean? And ultimately, what does it mean for us? As you listen now to the night, the faint hum of distant engines, the soft sigh of wind in the trees, you might sense, beneath the surface of ordinary experience, the hidden tide of information flowing through all things. It is in the crackle of static from a distant star, in the spiral of a seashell, in the quiet logic of your own breath. Every moment, the universe is whispering its secrets, offering clues to those who are willing to listen. And so, as the world spins onward through the shadows, as the stars wheel overhead in silent procession, the mystery of information remains, not a riddle to be solved, but an invitation to wonder. For in every question asked, in every answer glimpsed, we become both seekers and storytellers, participants in the endless dialogue between matter and meaning, between the whisper of stars and the echo of our own longing to know. As our journey through the shimmering threads of information drifts to a close, we find ourselves cradled in the quiet glow, where every spark of knowledge softly pulses like a comet tail fading into the hush of space. May this gentle wonder linger in your mind's twilight, inviting peaceful dreams to unfold. Until we meet again, return with open hearts for more Dreamtime tales that dance among the stars.